I was recently asked how to determine the maximum or minimum points, which are the turning points of a quadratic equation. Okay, now there are two methods you can use depending on the type of question they ask you. If they ask you to find the maximum or minimum point of the quadratic equation or determine it without showing your steps, you can use method 1, which we learned in chapter 16, which tells us that the quadratic equation is in the standard form ax squared plus bx plus c. Okay, now if the coefficient of x squared is positive, if a is positive, it's going to be a u-shaped graph, and the minimum point is the vertex at u. If a is negative, or the coefficient of x squared is negative, then it's an n-shaped graph, and the vertex is the maximum point at the top. Okay? But in calculus, if they ask you to determine the maximum or minimum point using the derivative or showing your steps, then you have to use the derivative and use this rule. And this is what I think most are being confused about, using this rule. So how do you apply this rule to find the maximum or minimum point without using the graph? That's what I'm going to show here. Basically, your first step is going to be finding the derivative of your equation, your quadratic equation. After you do that, take the x value and use this rule. Okay, if your x value is positive, you're going to place it between negative and positive. Okay, now note that the gradient is descending here. It's a negative gradient, and here the gradient is increasing. So the graph is resting at the minimum point, because we start from left to right, right? So moving from negative to positive is going to be a minimum point. The graph will have a minimum point because from left to right, the gradient is descending and then increasing. The graph is resting at the minimum point. If your x value is negative, you will place it between positive to negative. Between positive to negative, if we start from the left to right, we're going to start from here. The graph is increasing first, resting at the maximum point, then descending. So from positive to negative, you will have a maximum point because the graph will be resting at a maximum point. Now keep this rule in mind, because this is the rule that we will use to solve this equation in steps, to show the steps and determine the maximum or minimum or the turning points of the quadratic equation.